Hello. I hope you are doing well. I am doing great. Thanks for asking. In this video, we'll talk about how you can create your own version of dplyr filter in Bizarre. So first of all, let's have a look at what dplyr's filter does. So dplyr filter, I meant filter. Okay. My machine is taking a second or two because it's recording, but here we are. Filter keeps rows that match a condition. The description is the filter function is used to subset a data frame, retaining all the rows that satisfy your conditions. To be retained, the row must produce a value of true for all the conditions. We are going to stop at that. We don't need the rest of the functionality. So for the usage, we can say that filter is a function which takes .data and the ellipsis. We don't need the rest of the arguments for our case. .data is a data frame extension, a table, blah. The ellipses are of course expressions that return a logical value and are defined in terms of the variables in .data. Then if multiple expressions are included, they are combined with the AND operator. Only rows for which all the conditions evaluate to true are kept. So basically you can just take iris, then you pass it to dplyr filter and say, I want you to filter out for me where sepal.length is greater than let's say 6, right? And if you run that, you can see that, let's check the number of rows. So for this one has 61 rows, and when you add a condition, for example, and or not and actually you can just use a comma. If you add a condition, let's say species equals to setosa, so there isn't such combination where the sepal length is greater than 6 and then the species is setosa. So in this case we get a zero row data frame. But if we change this to something like species, let's try Virginica. Okay, there we go. And then we check the number of rows. This one has 41 rows. You get the gist. We are going to create such a function. So for a start, let's create a directory and we'll just call it filter, and then we'll cd into that directory. After cding, we'll create a file and we will call it filter.r. Then now if we open this in NVim, actually before opening, let me just split my screen. So tmax new session, I'll just call it filter, and now I can open this in NVim. Now I'm inside of the file filter.r. We've said that we want to create a function called filter. It's a function of .data and ... And then, of course, the first thing that we want after we get into this function is to capture the dots. So we'll say dots will be match.call. If you remember, match.call is a pair list, and we don't want to expand the dots, right? So we'll just say expand dots to false. Since it's a pair list, I can subset the ... Pair lists behave the same way as lists, so I can subset the ... dots. After that, we now have a pair list. We want to evaluate the expressions in this pair list. For that, we will use the eval function, and if we check the docs of eval, so let's check the docs of eval. Eval evaluate another expression in a specified environment. Now, expr is an object to be evaluated, and vir is the environment in which expr is to be evaluated. May also be null, a list, a data frame. In our case, we have a data frame, so we know we are in the right direction. And for example, let's say you have an expression or a call like x is something like, let's say, quote sepal.length. We can say I want you to eval x and then the environment, so envir is iris, and this should return like the sepal length. Same for like if we have, let's say we quote something like species, and if we say I want you to evaluate x and the environment is still iris, you can see this time we get the species. And you can as well use eval q. In this case, you just say I want you to eval q species, species, and the environment is iris, and it will still work the same. So eval q, the difference between eval and eval q is that if the eval q is the eval q form is equivalent to eval quote expr. Eval evaluates its first argument in the current scope before passing it to the evaluator. Eval q avoids this. So yes, in our case, we'll just need eval. So we come here and say, since dots is now a list, we have to go through it step by step. Like we have to loop through the list. So we are going to say, I want you to apply to dots. The function is eval, and then eval eval needs an environment, so we'll just pass in envir, and the envir is dot data. This will return a list. After returning the list of, well, logicals, we want to reduce this list into a single logical vector. So we'll say reduce, and the function will be end. These are the row indices. After that, we'll just subset. So dot data subset row indices. Yep, our function is actually complete, and we can test it by just having, let's say, iris. We pass it to filter, give me where the species are setosa only. Yeah, let's take it for a spin run. If I just say r script, not server.r, it's filter.r, you can see that this actually works. And let's say, let's just get the number of rows. Then we can as well say iris, I want you to filter where sepal dot length where sepal dot length is greater than 6, for example. Then we check the number of rows, of course. So if we do r script filter.r, 50, 61, it's working as expected. If we do iris, and then I want you to filter where let's say sepal dot length is greater than the mean of sepal dot length. So all these expressions are being evaluated in the context of the data that we pass, in this case iris. So I want you to evaluate this and just return me the number of rows. So if I run that, works, then maybe a final test, we take that and we pass it to filter sepal dot length greater than the mean of sepal dot length. Oh god, length. And also where the species is, let's try Virginica, then get me the number of rows. Yep, looks about good. Let's try that. So r script filter.r, and it works. So there you go. We now have our own version of dplyr filter. Thanks for watching, and you have a good day.